Greetings to all my tech heads out there in KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at static routes. We'll be discussing the types of static routes, next hop options, IPv4 and IPv6 static route commands, and then finally we'll take a look at dual stack topology. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Static routes are common in today's network. Most networks use a combination of static routes and dynamic routing protocols to get traffic to move across their network. There's places to use static routes, there's places to use dynamic routes, and when we combine those together, we get very effective paths across networks to deliver those data to the people who need them. IP version 4 and IP version 6, they support four types of static routes: standard static route, default static route, floating static route, and a summary static route. The command to get in to use these is IP route, and that would be for IP version 4, and IPv6 route, that would be for IP version 6. When we talk about static routes, we need to talk about next hops. A static route typically doesn't get data to its final destination. What a static route does, it gets it closer to its final destination. If you're on a router and the network is directly connected to it, we don't have to route it. We can route it to those directly connected networks and deliver to the end devices. But if we are sending it to a remote network where we're on one router and we have to go through another router to get closer to the destination, that's what we have to do. We have to send it to the next hop. That next hop is that next router. Now, a couple ways we can identify the next hop. We can identify it by the IP address, IP version 4, IP version 6. We can identify it by the exit interface. What interface do we have to go out of on the router we're on to get to that next hop, that next router, to get it closer to its destination? And then finally, we can combine both of those, the IP address and the exit interface. Now, how we specify those creates one of three types for next hops. The next hop route is the IP address of that next router. And so what we're looking at here, typically we put in an IP address at this point. It can be an IP version 4, IP version 6, but it is an IP address we put in there. To create a directly connected static route, this directly connected static route, it goes out an exit interface. And so it goes out here an exit interface. That gets, when the router says, okay, we need to send it out, we're going to send it out this interface. We're going to send it out gig 001. We're going to send it out serial 010, and that's going to get it to the next router, which is connected to the other end of that connection, and that'll be one step closer to the final destination. And then finally, we have the fully specified. That fully specified is an IP address and the exit interface. So the exit interface, that's where we use both of them. To create a static route in IP version 4, we use the IP route command. You do this in global configuration, and so it's part of the IP suite we're dealing with. Specifically, we're looking at routing, so it's IP route, and then you put the network address in here. The network address for an IP version 4, it ends in zeros, so make sure it ends in zeros. If you put a full IP address in there, 192.168.10.10, it's going to throw you an error. But if you put the network address in there, 192.168.10.0, ends in zeros, that's what we're looking for right here. Then you put your subnet mask in. Whatever your subnet mask, for our class C address we talked about, 255.255.255.0. And then you have to do one of these choices. And right here, we have our squiggly bracket. Here on the left side, we have a squiggly bracket over here on the right side. What that means is you have to choose one of the options in there. And these vertical lines, this pipe right here, separates the choices you have to make. So either we have to put the IP address, and that would be the IP address of the next hop, or we need to put the exit interface. Then when we put the exit interface, we have the option, and this is the square brackets mean this is an optional address. So we can put in the exit interface, and then if we want to, we can make it fully qualified static route, and then we can put the exit interface with the IP address, but that's optional. Then at the end, this is another optional parameter you can put in here. This is the distance. This is the administrative distance. This is the trustworthiness of this connection. By default, if you don't put that in there, a static route gets a 1. 0 is a directly connected network. We trust that the most. The next one is a static route that gets an administrative distance of 1. Because you as the administrator set that up, we trust that above anything else, all the dynamic routing protocols. To configure an IP version 6 static route, commands are fairly similar. But once again, because we're dealing with IPv6, we have to make sure it says IPv6 here. Then we put the route keyword in here. Now, instead of the network address and subnet mask, we put the prefix in here. That prefix is some of your numbers, and then typically it's like 2 colons at the end. Because just like an IP version 4 address, this prefix, you can think of it as the network portion of the IPv6 address, that ends in zeros. If we put just 2 colons at the end, that says, hey, everything at the end is zeros. Then we put our prefix on the end, so that's a slash. And currently right now in our world, we typically use about /64, and that says, how long is my network portion? It's 64 bits. We're using half of that 128 bits there. Then following down here, we have the choice. We can either put an IP version 6 address in here, or the second choice is we can put the exit interface. And if we put the exit interface, we can also make it fully qualified here and put the IPv6 address in there. So we have the interface and the address. And at the end, we have the option here of putting the administrative distance on there. Very similar to the IP version 4 static route command. Another idea we should talk about in today's network, with IPv version 4 being what most companies use, but we are slowly migrating to IPv6. A lot of companies are running what we call a dual stack topology, What that means is we're running the IP version 4 stack protocol, and we're also running the IP version 6 stack protocol. We're running 2 stacks at the same time. If we look at our diagram here, we can see that this network address here has an IPv4 address. That's the top one, 172.16.1.0/24. That's IP version 4 here. And it also has an IP version 6, 2001:DB8:ACAD:1:1. Once again, remember, this is the prefix. This is the network portion. So it ends in a colon that says this is all zeros here, and then we put our prefix in here. We are running both of those. So the PC is going to have an IP version 4 address and an IP version 6. The routers are going to be able to handle IP version 4 and IP version 6. We're running that dual stack. We're running both of those together. I hope you're liking this episode on static routes. If you have the time, please leave a comment and let me know what you think about static routes. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When we start up our router and we start configuring interfaces, before we do any configuring, before we do static routes, before we do any dynamic routes, there's a starting routing table. And they base that off of the interfaces that you configured. If we look here in this example, this is for IP version 4. We do a show IP route. And then we filter. Once again, that filter is this up and down pipe sign and says begin. So wherever they find the keyword after this, wherever they find the word gateway, start displaying that and display everything after that. And so what it does is when we do the show IP route, remember how it would have all the codes up there at the top? We skip all that. First thing it says here is the gateway of last resort is not set. That's fine for now because we're concentrating on the other information. Then we have the routes listed here. Remember, when they first started this, they used class-full addresses. And that's where we get this. One line starts out here, these others starts out here. And how they do this is they use the class-full address, so 172.16, that's a class B address. And so the difference between the network portion and the host portion is right here. So this is network, this is host. It turns out it's a /16. Any networks that fit underneath that, because now we don't have to follow the class full, we can do class list. So instead of a /16, we can do a /24, we can do a /32, we can do a /17, 18. It doesn't have to be on that class full split anymore. The class list addresses are all what we call childs underneath the parent here. So the parent is out here at the top. These are all childs down here. If we look here, these all belong into the 172.16 class full address. The first two octets are 172.16. That makes it all part of that. But because we can now subnet, make smaller networks in there, there are different networks. And we have down here, we have a .2 network and a .3 network. There's two networks we know about. And if we can see the codes here as the C, that stands, this is a directly connected network. L means this is the local address. This is the IP address of the interface that it's connected to. Reason we have this out here, this L, this local address, this local route, is if traffic is destined for the router, we will match this and just route it to ourselves. That way we don't have to forward it out any ports, and we do a match saying, hey, this is our IP address, we'll take care of it. We don't have to worry about forwarding it. And every interface you configure, every IP address, they're going to get both of these entries. One is the local address, and then one will be from the network it can figure out that you set up with that IP address. And so you set up a 172.16.2.1 network, an IP address, you gave it a /24 here. If you give it a /24, that is this network down here. And so each configured interface gets a C and an L. We have a second interface that's configured, and that's on the 172.16.3 network. Those are the routes we know about. Because we configured those interfaces, they inserted that into the routing table because they're directly connected. We can route to them because they are connected. We know about them. We can deliver them to their final destinations. Now, let's go ahead and ping 172.16.2.2. 172.16.2.2, what we do is we look at our table here. Give me a second. I'm going to erase this information up here. Okay, clean that up. And I'm just going to go ahead and circle these two networks because these are the directly connected networks. These are on my two interfaces, serial 010 and gigabit Ethernet 000. These are the two networks I know about. They are directly connected to me. I'm going to go ahead and ping 172.16.2.2. What happens is we look in our routing table. Is there a match? 172.16.2, these three match. And if we look up here, that's our network portion. And so we know how to get to that network. We can then route it out. Serial 010 gets there, and then it can have the return trip to send back that echo response. We are able to successfully ping 5 times. Now, R1, you're going to go ahead and ping 192.168.2.1. If we notice the success rate is 0, we didn't get any replies back. We were unsuccessful every time. Why is that? Look at our network, or look at the address we're pinging, 192.168.2.1. Is that any of the networks we know about? We know about 172.16.2. Well, first octet's 172. We're trying to ping 192. That's not working. We know about the second network, 172.16.3. Well, once again, we're trying to ping a 192 address. We don't know how to route it to get closer to its destination, how to get to its destination. Because we don't know how to get it to its destination, it's going to fail. And that's why pinging the 192.168.2.1 address fails. We don't know how to get to that network. Our routing table is very limited at this point in time. So this is the starting routing table. The IP version 6 starting routing table is basically the same. We look here and we can see we have a C and an L. That's for our serial 010 interface, serial 01 interface. The C is for our directly connected network. Notice this network address, it ends in zeros here. Then we have the L for that local address, and this is a complete IP version 6 address. It does not end in zeros. Also notice it's a /128, so it matches all 128 bits of that address. That is the IP address of that serial 010 interface. If we get information for that address, we know it's for us. Next, we have a C, an L, and an L. You have to remember with IP version 6, we a lot of times get 2 IP version 6 addresses on an interface. One is our global unicast address, which this one is 2001 DB8 ACAD :3:1. And once again, we match the full 128 bits. And the other one is our link local address. Remember, a lot of times you set up a global unicast address and a link local address on your interfaces. And then we have the network here that we derive from our global unicast address. And once again, that ends in a 0 here. And we're only matching a part of it, the network portion, the prefix portion. When we come down here and we issue a couple of ping statements, first ping we issue is 2001 DB8 ACAD :2:2. Here is the network portion of that address. When we look in our routing table, and give me a second, let me erase some of this information up here, clean this up a little. And then I'm going to quickly circle our network addresses we know about. Those are the directly connected networks. We have 2 directly connected networks. Our first ping here, 2001 :DB8 :ACAD :2. We look and say, do we know how to get to that route or get to that network? 2001 DB8 ACAD :2:. Yep, we matched the first 64 bits. Yes, we can do that. And so they route it to the destination. The destination sends back the reply, and we get a success rate of 100% right there. Now, our second ping, we ping the 2001 DB8 CAFA :2:1. Let's go ahead and look for this network portion, 2001 DB8 CAFA :2. Do we know how to get there? 2001 DB8 CAFA. Nope, that's not it. Next network we know about, the second one, 2001 DB8 :CAFA. Nope, we don't know how to get that. So we don't know how to route to that destination. Same thing that happened in IP version 4. We get a ping and we don't know where to send it because our routing table is limited. Those are all the routes we know about. Those are all the networks that we know about. And so that ping will fail because we can't get it to its destination. And right here we can see we have a success rate of 0 because there's no route for the destination. It was my pleasure to provide you with this wonderful episode on static routes. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.